guys, I got something here that's a little interesting. I think it'll make your boat float. Let me lay it on you here. Alright? Just read along with me. You see it says titanium custom designed turning fixture, right? What the fuck's that mean to you? Not much. And I put under it machining porn. Why did I put that? Because this is a kinky little fucking fixture. I think it'll give you a big hard on. Hang on now. Let me read and elaborate. Here's what it says. Well, we will display an existing turning fixture. We've had this for a few years, using it works well, right? But at this point, we got a better design, so we're in the process of improving the design. Well, the old design, which is what we're going to show you, is not exactly chopped liver, it's cute. Because of its hybrid design, like that word hybrid, huh? We believe it's worth viewing. Alright? So we're gonna lay it on you, and here's what I want from you. You see that? I wonder what that means. Alright? Are you getting my drift?
Hello everyone, my name is John Peters of Apple Machine and Tool Company, and what we have here today is a blueprint drawing of a part that I have to manufacture for a customer of mine. And to tell you a little bit about it, the material is titanium 6AL4V, which I've been working with now for about 30 years, so it's a lot easier than when I initially had started. But to get back into it, what this part is going to become a standoff for a light ring, LED light ring camera assembly for underwater observation for an oceanographic camera. So let's get at it. So this part, it looks pretty simple. As you can see, there's a blown up view here of 5 times. It shows you it has a 1/4 thread on the end from the face back to the shoulder, 1/4 inch. The opposite side of this shoulder, 400 thousandths. And then it drops down to a 1/4 inch diameter. Now, that was the issue I originally had about how to go about machining this part. And the overall stock diameter I start with is 5/16 diameter. So it's got to go from 5/16 down to 1/4 inch. And I can't have a center hole on this end. It's not allowable. I had thought about initially trying to single point this, but being so small in diameter, when I got away from the center, you know, a rigid point where it was being supported between the center and the chuck of the lathe, this would be influenced. It'd bend like a piece of spaghetti, like a wet noodle. So I came up, you know, with a little design, a little thought and design of a better approach to machining this part to achieve the tolerances and a good outcome. Anyway, what I want you people to do is think about how you would approach a job like this and go about machining it to get the finished product into spec. I'll bring you along. What I have here is I start with a piece of 5/16 diameter titanium rod that's cut 19 3/4 inch long, and this allows me to get 2 parts. I piggyback the parts, and there's a little bit of waste, about 1 inch of waste, and that allows me to hold on to it in the 5C collet setup that I use to machine this. And we go from the raw stock, and what I'm going to show you, this is rolling back because the table isn't level. We'll let it roll back and get it out of the way. This is the finished product right here. Sorry for moving it around. Right here is the finished product. You can see this is the 1/4 inch diameter from this shoulder to the end face, which, you know, represents this to that. And what I'm going to show you is the approach that I took, how to get there. And now we're going to go to the lathe and we're going to go about machining this, and I'll show you how I got there.
Hi guys, what we have here is a titanium part I'm making. The part, the overall length of the part is 9 inches, 350 thousandths, as you can see it right here. It's a 5/16 diameter. I have it fastened in a 5C collet. What I did is I have to turn the 5/16 diameter down 1/4 of an inch for a length from this face to a shoulder of 8 inches, 950 thousandths. And I made this special tool up to do so. This little block out of cold rolled steel, and it has a bronze bush in here that has the 5/16 ID, a thou bigger than the OD of this. And there's 2 carbide tools within right here in this little window. You can see the coolant running down, and that turn it down to 1/4 inch diameter. And in back of these tools is 2 little bronze pads that act like a steady rest that capture the 1/4 inch diameter to give it rigidity. Now we'll start it up and you can see it in action. I'm approaching it here. I come in easy till it engages the bushing, the stock. I bring it up, engage the feed on the apron of the lathe, and you can see it start cutting. Only thing about this material, the chips are hard to break. This is 6AL4V titanium. I just have a pair of needle nose and I kind of help it out and clear it. But another little secret here is I have 2 tools. The one on the front side is conventionally, you know, it's facing upright. The one on the back side of center is upside down because of the rotation. You know, it's going counterclockwise. And well, this is really bunching up more than usual. Let me clear this out here. Usually it curls up. But one tool is ahead of the other, just about 5 thousandths. And one's roughing and one's finishing, you know, at 2 different diameters. And how I get the shoulder to line up is I have a 10 thousandths radius on one, so it, you know, they both blend in when I get to the shoulder. And you can see, you know, it's in action here, and it's cutting. And it works well. It doesn't chatter or nothing. Supports it, and it holds that diameter less than 1/2 thousandth of that 250, the target diameter, the finish of it on the OD. And you'll see in a moment here the 1/4 inch diameter will be coming out the back side, because this obviously has a through hole on the center line of the spindle of the lathe. You can see it. Yeah, he'll get over the top here. You can see it exiting right here where my finger just was. And it comes out a real nice finish. The only pain, like I say, is the chips. You can see it really good right there. And that's it. That's the magic, all in this little tool block, like a box turning tool. This technology's been around for a while. I just was fortunate enough to know about it and put it to use for this particular job. Thanks a lot.
Okay, guys, that's it. Back here, back at you again. Comment. Are you getting my drift? I'm out of here.